Hello, my name is Connor Hendrickson and I'm a PhD student at Southern Cross University, and my research area is on coral reef conservation and monitoring. Reef-building corals are amazing organisms. The relationship between coral and their microscopic algal symbionts is the foundation for one of the most important ecosystems on Earth. Corals are the engineers of habitats that support levels of biodiversity and productivity that are unmatched almost anywhere else on our planet. Just in the last 10 to 15 years, mass coral bleaching events have greatly increased in frequency and scale, becoming one of the most damaging processes to afflict marine ecosystems. Being able to quantify the severity of that bleaching is critical for monitoring the health of coral reefs. But measuring bleaching can be a difficult task. The best methods for measuring bleaching require laboratory tests on samples of coral tissue in order to work out the concentrations of coral symbionts and their photosynthetic pigments. But this lab work is time-consuming and requires that the tissue be removed from the coral in a destructive process. This limits the application of these tissue analysis methods to smaller scales. Divers and aerial surveyors have long used visual scoring methods to track bleaching of corals at reef-level scales, but these systems are difficult to standardize and less precise. My work involves developing methods that are balanced between these two approaches. Digital photography has also been used as a tool to measure bleaching severity. Camera sensors can detect small changes in color intensity while being faster than laboratory methods and more precise than subjective ranking systems. Normal cameras measure the intensity of light in 3 broad bands, but by increasing the number and granularity of the bands, it is possible to measure much smaller changes in color and even measure color intensity of individual pigments. This type of system is what is found in hyperspectral cameras. But all of these different methods have yet to be compared simultaneously. To do this, an aquarium-based experiment was designed that replicated the temperature and light conditions of a bleaching summer on the Great Barrier Reef. Throughout this experiment, hyperspectral scans, photographs, observer scores, and tissue samples were collected to track how well the different methods correlated to one another as the bleaching progressed. This data will be used to help enhance the accuracy and efficiency of coral reef monitoring. Reef monitoring data is used to inform management decisions and track the impacts of reef restoration efforts that are a vital part of ensuring the long-term health of such an important ecosystem. Thank you.